Hello, and welcome back again to our channel. Today we're going to do an all-comprehensive video on quadratic equations. I can see from your viewership that you guys are really interested in quadratic equation. And I don't know whether probably there's a little tricks in there that you want to make sure that you are getting it handy so that any problem that is presented to you, whether it's an exam or an assignment, you are ready to be able to battle with that. So I decided to do this comprehensive video for quadratic equations so that it will be your go-get-to. All right, it will address any form of tricks or any form of misunderstanding that relates to this topic. All right, so we're going to look at quadratic equations, but before we do that, we're going to look at the content of the video. And then the content of the video, the first thing is to look at what is a quadratic equation. Right, we're going to look at what is an embodiment of quadratic equation. All right, that's the first part. That's section A. The section B, we look at the three methods, of solving a quadratic equation. The first method being factorization. The second is using a certain formula, which is this one here. It's a formula. The first method is factorization. Sometimes we have it in two ways, where the coefficient of x squared is equal to 1 or the coefficient of x squared is not equal to 1. We'll get there. We'll get there. I'm just giving us an idea of what the content of the video is going to look like. And then the third method is known as the completing of squares. The completing of squares method, that is when we cannot be able to factorize. If we cannot factorize, we use the completing of square method. And the last thing that we'll be looking at is roots of quadratic equation. Sometimes we might get some questions related to finding the roots of a quadratic equation, and then we're going to be able to look at that. So we're going to zoom straight right in, and we're going to start with what a quadratic equation is. What is a quadratic equation? Now, the first clue there, all right, the first clue there is what we call the equation. Okay, how do we know something's an equation? If it's an equation, if it has an equal to sign in there. If you have an expression, if you have a mathematical expression, all right, containing an equal to sign, containing the equal to sign, all right, then that makes it an equation. However, it's quadratic if the mathematical expression has the highest degree, the mathematical expression, the highest degree of that expression, highest degree is 2, all right, highest degree is 2 or is squared, all right. So a quadratic equation is of this form, is of the form ax squared plus bx plus c. This is, and it's equal to 0 because it's an equation, right? So once you have an equal to sign there, equal to 0, we know this side gives us the equation part. And then this expression here is what makes it quadratic because the highest degree here is 2. Can you see that? The highest degree there is 2. So now, let's break it down. This a here is known as the coefficient. It's very important. It's known as the coefficient of what? Of x squared. This is what is called x squared. So the a attached to it is called the coefficient of x squared. Now the b part, this one here, this b here, is known as the coefficient of x. It's known as the coefficient of x. And then we have the constant coefficient. This one here is known as, the c here is known as the constant coefficient. So basically, this is a section A, the A part of this video, quadratic equation. It's a mathematical expression of the highest degree being 2, and it contains an equal to sign. All right, and it's of the form. So this is the first part. It's of the form. This is of the form. A quadratic equation is of the form ax squared plus bx plus c is equal to 0. And then we said the a is the coefficient of x squared, the b is the coefficient of the x, and then the c is the constant coefficient. Now we're going to look at the three methods. We said there are three. The B part of the video says we're going to look at the three methods of quadratic equation, how we can be able to solve a quadratic equation of quadratic, all right? And then we're saying that the first method is known as the factorization method. The factorization method. And this factorization method, we said it's of two forms. It's of two forms where you have the coefficient of x squared. Remember the coefficient of x squared? The coefficient of x squared is equal to 1. So we're saying that if we have something like this, maybe ax squared plus bx plus c, we know this is a quadratic equation, right? But if the a there is 1, we're going to use that method. So basically x squared plus maybe bx plus c. If it's of this form, then we use the factorization method, the first part. This is the first part of the factorization method. Now the second part The second part is where we have the coefficient. We have the coefficient of x. The coefficient of x is actually not 1. The coefficient of x squared, sorry, coefficient of x squared is not 1. It's not 1. So basically, if we have ax squared plus bx plus c being 0, if we have something like this, we are saying that this a is not 1. It's not 1. The a there is not 1. So pretty much we're having something like this. You're having, let's say, 2x squared plus bx plus c is 0. So here we can see this is not 1. So we can apply the second part. Then we said that the second method is a formula. The second method is a formula, and then the third method was completing of squares. Completing of squares. So we're going to take them one after the other. We're going to start off with the factorization method. So let's start with the factorization. We're going to look at factorization method. The factorization method, which is the first method, right? Is the first method, and we're saying that with the factorization method, we're saying that if we have factorization method, we have the first section, all right, the first section of it, and we're saying that this first section is where you have the coefficient. We have the coefficient. Don't forget, we have the coefficient of x squared is equal to 1. So we give an example that if you have ax squared plus bx, which is the quadratic equation, plus c is equal to 0, then if the coefficient of x squared is 1, then we are looking at this. It's basically we are looking at x squared plus bx plus c is 0. Then we're going to use this method. So let's pay attention. So let's maybe take an example. All right, let's take an example. Let's say we have this problem right here. Let's say we have x squared. Yeah, we have x squared minus 2x. Yes. Minus 3 is equal to 0. Now, the first thing we're going to identify is here. We can see here is 1. It's like 1x squared minus 2x minus 3 is equal to 0. Once we have this, we're going to use this first method. The first method, once this side is 1, all right, we look at this term here. That term is negative 3, all right? Once we have negative 3, this side here, anytime this side is 1, look out for the constant coefficient, and it's negative 3, not 3, please. It's negative 3. Please pay attention. It's negative 3. The negative is important. It's in front of the 3, so it's negative 3. Now we are going to look for the factors. We're going to look for the factors of negative 3. We're going to look for factors of negative 3. And these factors of negative 3, when we multiply the factors of negative 3, we should get negative 3. When we multiply the factors of negative 3, we multiply the factors of negative 3, we should get negative 3. And when we add the same factors, we should get negative 2. Where is this negative 2? This one right here. Don't forget, we should get negative 2. So we're going to look for factors of negative 3, but we should make sure that the factors that we are looking for, factors means two numbers. When we multiply, we get that number. So factors of negative 3 means two factors, two numbers. When we multiply, we get that negative 3. But at the same time, those two numbers that we're multiplying to give us that negative 3, when we add them together, we should get a negative 2. So I hope that is clear. So someone can say that. Someone can say that, okay, what about negative 3 times 1? It will give us negative 3, right? It will give us negative 3. But with negative 3, the same negative 3, when we add it to 1, negative 3 and 1, when we add it, are we going to get negative 2? Yes, we're going to get negative 2. And if that's going to work, it means that it has satisfied our condition. So when we add, we should get negative 2. When we multiply, we should get negative 3. Can you see that? So the factors are pretty much negative 3. The factors are negative 3 and 1. Can you see that? So that when we multiply these two, we get negative 3. And we add, we get negative 2. Is that okay? So once we know that, it means that our answer, x squared, which is minus 2x minus 3, our answer is going to be x minus the 3, this one here. And it's also going to be x plus the 1, this one here. And then we equate it to 0. Can you see that? Therefore, x minus 3 is going to be equal to 0, and x plus 1 is going to be 0. And then x is going to be 3, and x is going to be negative 1. Can you see that? This one is going to come here. Becomes plus 3. 0 plus 3 is 3. And then this is also going to come here, changes to negative 1 because it crossed the equal to sign. And it becomes 0 minus 1, which gives us negative 1. So the trick here is always looking out for we're always looking out for the coefficient of x squared here. We want to make sure that the number here is 1. If it's 1, we just look for the factors here. And once we know the factors, we don't need to solve anything. We all just have to use x and that factor. So if they say the factor is negative plus 5 and maybe negative 1, it's going to be x plus 5, x minus 1 is equal to 0, like that. Whatever the factors are, you pick those two numbers and bring them together, and then you're good. You're good to go. All right. Another way, the same, we're still on that same same question, where we're saying that is x squared minus 2x minus 3 is equal to 0. We can see that here is also 1. That's the first thing we check. So if we check, we say that the factors, we agree that the factors of negative 3, when we multiply to get negative 3, we said it's negative 3 and 1. Can you see that? And then when we add, we get negative 2, this one here. And it's still negative 3 and 1. When we add them, we get negative 2. When we multiply them, we get negative 3, right? So these are the numbers. It's going to be this and this. So it's going to be x squared minus 2x minus 3, which is 0. It's going to be x squared. The first factor is negative 3. So it's going to be negative 3x. Can you see that? And the second factor is plus 1. It's going to be plus x or plus 1x. And then we're going to have negative 3, because this whole thing here is what is giving you this. So you don't need to repeat it. These are two factors that you have found, and then you're just going to bring the negative 3, then you equate to 0. Can you see that? Now we are going to group them together. X squared minus 3x. We bring them together. Plus x minus 3 is equal to 0. Now, if you look at this, we factor x out. So x comes out. You have x inside minus 3 plus x minus 3 is equal to 0. Now, this is going to be x plus 1 and then x minus 3, because they are the same. They can go into 1. And then we come here. When we come, you have x plus 1 to be 0. And we also have x minus 3 to be 0. And then we're going to have x is equal to 0. This one has to come here. So the sign plus will change to negative 1. This is also going to be x is equal to 0. This one comes here. It goes to become plus 3. And we have x is equal to negative 1. And you have x equal to 3. Can you see that? So this is another way. After finding the factors, you can work it out this way to arrive at these two answers. You can be able to get there. Otherwise, you don't need to work all this. All you need to do is that once you know this and this, you put them in the parentheses, and then that's your answer, and then you save yourself some time. And this is is a very shortcut if you're doing an objective problem that like you have a possible answer and you don't need to show working. Then this one that we did, just putting them in parentheses will be faster and quicker for you to solve the problem, and then you go your way. But if you are being asked and being demanded to solve it, then you have to go through all this tall order. So this one gives us the holy grail for the first method, factorizing. Having a way to factorize the quadratic using the first method. All right. Now we're going to tweak it a little bit. Let's say that I've been asked to factorize. Let's say 2x squared minus x minus 1 equal to 0. Let's say we are going to factorize this, for example. Now, you can observe that this side here is not 1. It's greater than 1, right? If it's greater than 1, we cannot use the first method. We cannot use we are going to use the first method, which is factorization for sure, but we're not going to use the first one that we did, where we just focus on this negative 1 and then we solve that thing and win our way. We can't do that. So because this side is not this one here is not 1, all we're going to do is that we multiply that we multiply the coefficient. So the coefficient of x squared, all right, would multiply the constant coefficient. We'll multiply the constant coefficient. All right, we'll multiply by the constant coefficient. And I hope you know what the coefficient of x squared is. We know that the coefficient of x squared is 2. We multiply it by the constant coefficient, which is negative 1. And then we end up getting negative 2. So that's what we're going to look for. We're going to look for the factors. We're going to look for the factors of negative 2. And this time, when we multiply, we're supposed to get negative 2. But when we add, we're supposed to get what? Negative 1. Can you see that? We're supposed to get negative 1. So what are the numbers? Somebody can say 2 and negative 1. Let's say we are going to pick these two numbers. Let's say 2 and negative 1. When we multiply these two, we're going to get negative 2. It satisfies this one here. But when we add 2 and negative 1, do we get negative 1? No, we get positive 1. Can you see that? Because it's 2 in your wallet, you owe 1. The one is going to be a change for you. All right. So this doesn't work. So can we turn it around? Yes, I think we can do that. by saying that the factors are negative 2 and 1. When we multiply, we're going to get negative 2, but when we add, we're going to get what? Negative 1. It satisfies the requirement. Can you see that? It's 2, it's negative 2 and 1. So basically, and this time you cannot be able to put it in bracket. You can't say x minus 2, x plus 1. You can't do that because the coefficient here, the coefficient of x squared is not 1. You only do that when the coefficient of x squared is 1. But since it's not equal to 1, we're actually going to solve it. We're actually going to solve. So we're going to have our 2x squared minus x minus 1, which is equal to 0. It's going to be 2x squared. The first factor is negative 2. So it's going to be negative 2x. The second factor is plus 1. It's going to be plus x. And then we bring this negative 1. We don't bring this negative x there again, because that negative x is the whole of this. All right, and we just bring our negative 1 is equal to 0. And we're going to have 2x squared minus 2x, we put it in parentheses, plus another x minus 1 like this is equal to 0. All right, now we can factor 2 out here in x. And what do we get? We get x, because if we multiply this and this, you're going to get back this 2x squared. Can you see that? If you multiply 2x by negative 1, you're going to get this negative 2x plus x minus 1. Always, this number and this one here, the factor here, this should be the same. That's a sign that you're on the right track. Let's bring it here and continue right here. So we're going to have 2x, x minus 1 plus x minus 1, which is equal to 0. That's what we are having. And then we are going to have 2x, this 2x, plus the invisible 1 here. We'll go into one parenthesis, and this x minus 1 will be in one parenthesis, go to 0. So that 2x plus 1 is equal to 0, and then x minus 1 is equal to 0. This whole thing is equal to 0, and this one too is also equal to 0. So that 2x is going to be 0 minus 1. This one comes here, changes to negative 1, because it crossed the equal to sign, all right? It crosses the equal to sign. Now, this is going to give us 2x or negative 1. All right, and then we're going to have x is equal to negative half, and this is going to be x is equal to 0 plus 1, and x equal to 1. All right, so I hope this is clear. This deals with all that we need to know about the first method. So the first method can be done in two ways, where the constant the coefficient of x squared is 1. There's a shortcut to that, right? And then if the coefficient of x squared is not 1, then we have to go through all that, where you take the number that is here, multiply by the number that is here, and find the factors of that number, so that when you multiply, you get that multiplication together, and then when you add, you get the number that is here. Don't forget the negative numbers. Very important. So this ends the first method. Then we're going to look at the second method. We're going to look at the second method of solving quadratic equations. So second method of quadratic equation, and we said that one is the formula. There's a formula in solving the second method of quadratic equation. That formula, we're saying that it is x is equal to negative b plus or minus square root of b squared minus 4ac, and you divide everything by 2a. All right, so the first thing we always do, if you're given a problem, you have to set up that formula first, and then we identify the variables in there. Once we identify the variables, we can be able to plug it into the formula right there. All right. So let's say that we have a question. Let's say we have been given 3x squared. Let's say we have 3x squared minus 4x minus 1 is equal to 0. Let's say we have something like this, right? The first thing we're going to do is to set up our quadratic expression, ax squared plus bx plus c is equal to 0, so that we can be able to identify what is here, because this x squared and this x squared are the same. Can you see that? So it means a is 3, and then it also means that our plus b is equal to negative 4. Can you see that? And then our plus c is also equal to negative 1, like this. Once we have this, we can plug into the formula. Can you see that? It means that our x is equal to negative b. What is the b there? It's negative 4. Don't forget, the formula says negative b. So negative b, this b is negative 4. Plus or minus square root of b squared. What's our b? B is negative 4. We squared minus 4a. What is our a? 3. What is our c? Negative 1. Can you see? And we divide everything by 2a. Our a there is 3. And then we begin to solve. So negative times this negative becomes positive 4. Plus or minus square root of negative 4 squared is the same as negative 4 times negative 4. And that gives us plus 16. Can you see that? So we're going to have 16, and we're also going to get plus 12. Why? Because you have negative 4 times 3 times negative 1. This will give us negative 12 times negative 1, which is positive 12. And then we divide everything by 6. It was 2 times 3 is 6. And then we end up getting 4 plus or minus square root of 28 divided by 6. Now square root of 28 is the same as square root of 4 times 7. And it is the same as square root of 4 times square root of 7. We know this is 2. 2 square root of 7. Can you see that? So we are going to have it's equal to 4 plus or minus 2 square root of 7 divided by 6. So that we have 4 over 6 plus 2 square root of 7 over 6, or 4 over 6 minus 2 square root of 7 over 6. We split it because of this plus or minus. Is this plus or minus? So this is the positive side and this is the negative side. All right, and then we solve it. We will simplify it. 2 will go here, 2. 2 goes here, 3. 2 goes here, 1. It goes here, 3. 2 goes here, 2. It goes here, 3. 2 goes here, 1. It goes here, 3. So that we're going to have 2 over 3 plus 1 over 3 square root of 7. Or we're going to have 2 over 3 minus 1 over 3 square root of 7. And then we are good. So that is the quadratic formula. In doing the second method, you first have to write the problem that you're looking for and set it up with the expression ax squared plus bx plus c, and then look for the variables. Once we know the variables, we plug it inside the formula, and then we are good to go. We plug it inside the formula, and then we are good to go. All right. Now, the next thing we're going to do is to look at the third. We're going to look at a third method. We're going to look at a third method, and that third method is known as the completing of squares. It's the completing of squares method. I think I love that one. Many people don't like it. Completing of squares. It's simple. It's simple and easy, and you find out why I say so in a very short period. You're going to realize that it's one of the most easiest thing to do. So let's say we have 2x squared minus 3x minus 1 is equal to 0. All right. Now, you can always do this when you cannot factorize. All right. You will see that when we multiply this by this, we get negative 2, right? Negative 2. We look for the factors. When we multiply, we get negative 2, which will give us, let's say, 2 and negative 1, right? And then when we add, we get this negative 3 here, right? When we add, we get negative 3. 2 and negative 1, when you add, we're going to get 1. If we turn it around and we have, let's say, negative 2, sorry, if we turn it around, we have negative 2, we multiply to get negative 2. When we say it's going to be negative 2 and 1, and when we add, we get maybe negative 3. Negative 2 and 1 will not give us negative 3. It's going to give us negative 1. So both ways, it will not work. That tells us that we cannot use either method 1 or even use the quadratic formula. We can't use it. So we are stuck. We actually have to use the completing of squares. And the first thing we're going to do on our completing of squares is to eliminate. We should always make this 1, 1. This side, we need to eliminate it. So it's going to be 2x squared minus 3x minus 1, which is 0. We divide it by 2 so that constant, that coefficient becomes 1. We divide here 2 by 2. We divide it by 2. We divide it by 2. When we do that, we end up getting x squared minus 3 over 2x minus 1 over 2 is 0. 0 over 2 is to 0. Now, when we finish, we need to move this right here. So we're going to get x squared minus 3 over 2x is equal to 0 plus half. And that side is going to give us half. Can you see that? Now, the moment we get here, this is where you need to be paying attention. The moment you get here, always look at this term here. This, whatever you're having here, look at that term there. And when you look at that term, you see that it's negative 3 over 2. Can you see the coefficient of x there is negative 3 over? We have a negative 3 over 2. Can you see that? We're going to take half. We're going to do half of that negative 3 over 2. And that's going to give us half times negative 3 over 2, which gives us negative 3 over 4. All right? Keep this thing in mind. We're going to need it. It's very important, this one. We're going to need it. We're going to need it. Once you take the half of this thing here, whatever the number is, if you have 5 over 2 there, take half of it. It's going to give you 5 over 4. And then you keep it. Don't forget, in this case, in this question, half of negative 3 over 2, remember, the number there is not 3 over 2. It is negative 3 over 2. So half of that negative 3 over 2 is negative 3 over 4. We keep it. Now, once we have the negative 3 over 4, we square it. Okay, we square it. So we're going to get negative 3 over 4 squared. And once we square it, we add it. Add it to the left-hand side. And also add it to the what? And then right-hand side. So we're going to have x squared minus 3 over 2x. Can you see that? Plus, we said we're going to add. That's why I said plus. Negative 3 over 4. Can you see that? We said that when we squared what we are keeping, we squared the negative 3 over 4 squared. We've added to the left hand side, we've done that. We're going to the right hand side, which is half there, and we're going to add it to also negative 3 over 4 squared. Can you see that? So we've done the same thing. This is what we had here on the left hand side, and we only had this one, and we've added it to both sides. Can you see that? The moment we get here, then the fun begins. The moment we get here, we begin to have some fun. All right. The moment we get here, this whole thing that we've written here is basically x and this number that we kept. That number you kept. If that number is let's say plus 1, then it means it's going to be x plus 1, right? Don't forget, whatever number it is, you're going to add it to the x there. So we are saying that the number that we're able to we kept there is going to be x and this number here, and then we square it. So we are saying that this whole thing that we have written here is the whole expression here, and then that's going to give us the right hand side, which is the half plus the negative 3 over 4 squared. Can you see that? And then we solve it, and then we solve it, and then we solve it right there. We solve it. So I'm going to create some space here and begin to solve it right there, and then we are good. Can you see how easy it is? It's not difficult. You take half. Once you take half, keep that number. Remember, this is the half that we got. Half of the 3 over 2 is what we got, and we used it. X minus 3 over 4 all the time. You keep it and you use it later. You use it later on, but you have to square it to both sides to show the factorization. So now we're going to have x minus 3 over 4. The square of that is going to be half plus 3 negative. It's going to be negative 3 all squared over 4 squared like this. It's going to give us half plus 9 over 16. X minus 3 over 4 all squared. All right. Now we're going to take the square root of both sides. You square root everything so that we can be able to eliminate the square over there. We take the square root of both, we're going to get x minus 3 over 4 all squared is equal to square root of half plus 9 over 16. And then we're going to get, we end up getting x minus 3 over 4. Can you see that? The square, and then the square root is the half, so that it will cancel out, and then we are getting inside square root of half plus 9 over 16. And basically we're going to have x is going to be here. It's going to be the square root. You should be able to simplify with this side. Plus 3 over 4. This one is going to move because we're looking for x. All right. We're going to look for x. All right. And when we square root, you're going to get plus or minus. It's going to be plus or minus. It's going to be plus or minus. All right. Now, I'll leave this one for you. I'll leave this one. This is fraction. Inside, this is going to multiply this. This is going to multiply. So we're going to get 16 plus 18, 34. We're going to get square root of 34 by square root of 32. All right, square root of 34. Okay, 16 plus 18 is square root of 34 over square root of 32 plus 3 over 4. And this, you can be able to simplify the 32 to be 4 square root of 2. 4 square root, and you'll be able to change this, and then we are good to go. All right, so that's the third method. The third method is a completing of squares. The completing of squares. Completing of squares method. The completing of squares method. Now let's look at, I'm going to do another one because the completing of squares method is not something people like it. So I'm going to do maybe 2 more. Now we have x squared minus 6x plus 7 is equal to 0. All right. Here, they've already divided it. Here it's already 1. So all we do is that we take half. We're going to take half of the negative 6. Don't forget the number is negative 6. And when we do that, it's going to be half times negative 6, which is going to be, this is going to cancel, to 3. We're going to get 1 over 1 times negative 3, which is negative 3. All right. So we're going to have we're going to have x squared. All right. After taking the half, and when we take the half, let's keep this number. Don't forget this number. We're going to get negative. We're going to get negative 3. We're going to get negative 3x. Can you see that? Because we took half of it. Half of it, of the negative 6, go negative 3x plus 7 is equal to 0. Now we need to move this here. In fact, that should have been the first thing we should have done. The first thing we should have done was to move it away. All right. So we're going to get x squared minus 6x is equal to 0 minus 7, which is negative 7. So we get x squared minus 6x is equal to negative 7. Then we take half of this negative 6, and we ended up getting x squared minus 3x is equal to negative 7. And we said that now we add this one. We square it and add to left-hand side and right-hand side. Do you remember that? So we're going to get x squared minus this 3x plus the negative 3. Can you see that? Negative 3 all squared is equal to negative 7 plus negative 3 all squared, like this. So that we're saying that this whole thing is simply x and the number that we kept. And we square it, it's equal to negative 7 plus negative 3 all squared. And we end up getting x minus 3 all squared is equal to negative 7 plus 9. Because negative 3 all squared is negative 3 times negative 3. And that's going to give us positive 9, like this. And then this side is going to give us 2. Because you have plus 9, you will let you owe negative 7. They have to give you a change. So we're going to have x minus 3 all squared is equal to 2. And we square root. Once you square root both sides, we eliminate this square. So we're going to get x minus 3 is going to be square root of 2, and x plus or minus, plus or minus. X is going to be plus or minus square root of 2 plus 3, because this has to come here. Plus 3, all right? Plus 3. And then that gives us, that gives us our answer. That gives us our answer. All right. Let's take a last one, complete or square last one, and then we'll move on to the roots of a quadratic. The roots of a quadratic. Okay. Now let's say that we have 2x squared minus 3x minus 3 is equal to 0. We always check. All right. If you multiply this by this, you're going to get negative 6. The factors of negative 6, when you multiply, you get 6, will be 2 and 3, right? 2, maybe 3 and 2, right? Or 3 and negative 2, we get, when you multiply, you get negative 6. But when we add, we get 1. And that 1 is not what is here. All right. When it comes to, we can flip it and say it's, let's say it's negative 3 and 2, you get a negative 6. But when you add, you get negative 1. If you make it double, if you make it positive and positive, it's not going to work. So basically, we're stuck with using completion of squares. And to do that, we said that we always have to divide by 2 so that we make that side 1. So 3x, when we divide it by 2, divided by 2, divided by 2, you end up getting x squared minus 3 over 2x minus 3 over 2 is equal to 0. Now we're going to move this one here. Okay, x squared minus 3 over 2x is equal to 0 plus 3 over 2, which is 3 over 2. Can you see that? Now we said that we take half off, so we're going to take half of the negative 3 over 2. And what do we get? We get half times negative 3 over 2. And that's going to be negative 3 over 4. So we're going to keep this. Don't forget that number. Half of that, half of this, we always keep it. We'll need it one time. We'll need it. We'll need it. We'll come back to it. All right? Don't forget. Don't forget, please. It's important. This is what you're going to need to to get an answer. All right? Now, once we have this, we're going to square it. We square it and add it. Square and add to left hand side and right hand side. So we're going to have x squared minus 3 over 2x. It doesn't change, whatever we have there. But we're going to add what we did. We squared. We squared this. And then we're going to have 3 over 2. We're going to add it to get this side to be negative 3 over 4. Also, all squared like that. So we square the side and then square that side. Whatever is happening on the left hand side, we squared. Whatever is happening on the right hand side, also we are also able to square it, and then we take it from there. All right. Now this whole thing that we have here is the same as this. What we kept here is the same as x, and that thing that we kept, which is negative 3 over 4, and then we square it, and it's going to be equal to 3 over 2 plus 9 over 16. All right. This is going to multiply this, we get 48. This multiplies, we get plus 18. This multiplies, we get 32, and that gives us 66 over 32. So we square root, all right? We square root, all right? We square root both sides. Let's say we square root x minus the 3 over 4 all square. We square root it, and we also square root 66 over 32. And then we end up getting x minus 3 over 4, the squared, and then we take half of it. It's got to square root of 66 over square root of 32. This cancels out. We have x minus 3 over 4 is equal to square root of 66 over square root of 32. But we need the x. So our x, this is going to go here. So x is going to be square root of 66 over square root of 32 plus 3 over 4. But remember, it's plus or minus. Anytime you take the square root of both sides, this side becomes plus or minus, plus or minus, plus or minus, like that, plus or minus, like that. All right? And then we're able to solve it. I hope the complete of squares method has become a bit easier for you. It's become a bit clearer and not difficult as it is. All right. I hope it's clear now. Now we're going to look at the roots. We're going to study something concerning roots of a quadratic equation. That's the third part of the third section, not the third method, but the third section of the video. Third section or last section, or the last section of the videos, to look at the roots. We're looking at the roots of a quadratic, roots of a quadratic equation, root of a quadratic equation. All right, and we're saying that in general, the quadratic formula for finding the root of the equation is this. Right now, remember that we talked about the formula: x equal to negative b plus or minus square root of b squared minus 4ac. Remember that, divided by 2a. Do you remember something like that? Now this part, the thing that is inside here is known as the discriminant. It's known as discriminant. All right. It's known as, so the b squared minus the 4ac is known as the discriminant. All right. It's known as the discriminant. All right, because it's able to determine the nature of the root, how our roots is going to look like. Anything within a square root, how it's going to look. So if the first condition is if the b squared minus the 4ac is greater or equal to 0, if it's greater than 0 or is equal to 0, then we are going to have two real roots. We're going to have two real roots. Two real roots. That means that it will take on a real number. You're going to get exact number, right? Right? You're going to get two real roots. All right. But if, on the other hand, if this b squared minus 4ac is greater than 0, then we're going to have two real and different. They are two real, but they are different or distinct roots. So they are going to be two real. They're going to be two real, but different and different. All right, but distinct. All right, but distinct. They are real, but they are distinct. All right. The third thing to talk about, we're saying that if the b squared minus 4ac is actually equal to 0, then we'll have two real and two equal roots. Two real and two equal roots. Two real, going to be two real, and they're also going to be two equal. Okay, two real and two equal. Two real and two equal. They are going to be real numbers, but they're also going to be equal. They're going to be the same roots, distinct roots, two equal roots. So this one, they are real, but they are going to be different. They are going to be different from each other. They're going to be two, but they're going to be different. All right, they're going to be different. Okay. Now, the last one, we're saying that if you have the b squared minus the 4ac and it's less than 0, that means it's negative. it means it's negative. If it's negative, then we have no real root, no real roots, no real roots, no real roots. It's not going to be a real number. It's going to be complex. It's going to be complex. Imagine you're going to have square root of negative 5 something because it's less than 0. And then we're going to have complex number. Remember, square root of negative 1 is I. Square root of negative 1 is I. So square root of negative 5 is going to be square root of negative 1 times 5, which is square root of negative 1 times square root of 5. And this is going to be I square root of 5 or square root of 5I. All right. So that makes it no real roots. That makes it no real roots. So those are the four conditions. When we talk about the roots of a quadratic, we're saying that the root of a quadratic is either the discriminant is greater than or equal to 0, or is just positive, strictly positive, or it's equal to 0, or strictly negative, or strictly or strictly negative. So we can be able to determine the nature, right? We can be able to determine the nature. Let's imagine that we have a question. Let's say we are being told that 2x squared minus x minus 1 is equal to 0. And they want us to know the nature of the roots. All right. And we know the discriminant. The discriminant is what tells us the nature of the roots, right? Don't forget that. It tells us the nature of the roots. And we know the discriminant is the b squared minus the 4ac. Can you remember? Now, we say that we can set this one as ax squared plus bx plus c equal to 0. So that the a is 2. Can you see that? The a is 2. And then the plus b is negative 1. Can you see that? And then the plus c is actually negative 1. So we can plug it in here. B there is negative 1. Negative 1 squared minus 4. The a there is 2. And then our c is negative 1. So we're going to get negative 1 squared is 1. All right. Negative 1 times negative 1 is negative 1 squared. And that gives us 1. Negative 1 squared, like this. And then this is also going to give us plus 8. Plus 8, because this is going to give you negative 2 times negative 4. It's plus 8. And we get plus 9. Now, can you see that? Upon doing that, our 9 is greater than 0. It's not greater or equal to. All right, it's greater than 0. So it means we're going to have two real roots, but different. They're going to be but distinct, because it's not greater than and equal to 0. Can you see that? not greater than it. So we're going to have two real and different roots. They're going to be two real, but they're going to be what? And they're going to be different. They're going to be different. If it's less than zero, if you imagine we had a -9 and it's less than zero, then what happens is it's going to be a complex root. It's not going to be real, but it's going to be what? A a complex a complex root. It's going to have a complex it's going to have a complex root. All right. So if they ask you to describe the nature of a root, that's what you're going to use a discriminant to be able to determine the nature. But you have to keep in mind the four. You have to keep in mind the four conditions. All right. We need to have the four conditions in mind, and then we take it from there. Now we're still on the roots of a quadratic. We're still on the roots of a quadratic, and we can be given a question. We can be given questions in different forms. We can be told to find the value of k. To find value of k, for which the quadratic equation, we have a quadratic equation kx squared plus 12x plus 9 is equal to 0. You can ask us to find the value of k. Okay, and this quadratic equation has equal roots. Has equal roots. Has equal roots. Now, do you remember that we still need, because we've been told that it's equal root, we know that our b squared minus our 4ac, which is a discriminant, should be equal to 0. If it has equal roots, then the discriminant has to be equal to 0. Now, what is our b? All right. What is our b there? All right. What's our a? All right. So we know that we have this kx squared plus 12x plus 9 is equal to 0. And we know the quadratic equations are ax squared plus bx plus c is equal to 0. Now, we can see that our a is k, our b is 12, and our c is 9. Can you see that? So we're going to plug it in as we have b squared minus 4ac, which is equal to 0. The b here is 12, and you square it minus the 4. The k, a there is k, and then the c there is 9 is equal to 0. So that this becomes 144 minus 36k is equal to 0. So that we have 144 is equal to 0 plus 36k. 144 is equal to 36k divided by 36 divided by 36. So that we end up getting k, all right? We end up getting 144 over 36 is equal to k. So k is 144 over 36. And then we cancel out. All right, we cancel out. 2 go here 18. 2 goes here 72. Can you see that? Yeah, 2 goes here 9, right? I believe, yeah, so 2 goes into 36, 18, yeah. Yeah. All right. 2 goes into that 72. 2 goes here 36. 2 goes into 72, 36. 9 goes to 1, it goes to 36, 4. So k becomes 4. Therefore, our quadratic, which was kx squared plus 12x plus 9, the k is 4. So it's going to be 4x squared plus 12x plus 9 is equal to 0. Like that. Like that. And everything becomes beautiful. Becomes beautiful. All right. So now, if the questions can change. They can tell us that if you have x squared minus 2 into 3k plus 1 with an x plus 7 into 2k plus 3 is equal to 0. We are given something like this. And we are being told to, they said the roots of this quadratic, they said the roots are equal. Okay? Roots are equal. If the roots are equal, it means that the discriminant, you know what the discriminant is, right? The b squared minus the 4ac should be equal to 0 because they are equal, right? Now, what do we do from here? We need to rewrite this x squared minus 2 into 3k plus 1x plus 7 into 2k. That's the question, right? And then we need to rewrite our quadratic. Our quadratic will look like what? A x squared, right? Plus b x plus c is 0. Now we can see clearly that our a here is 1. Our b is the whole of that. Can you see that? Our c is the whole of this. So a is 1. B is negative 2 into 3k plus 1. Can you see that? And then C is a 7 into 2k plus 3. And then we're going to plug it in. So B squared minus 4AC, which is 0, It's going to be squared. What is a b squared? Negative 2 into 3k plus 1 all squared, right? We have that all squared minus 4, and then our a is 1, and our c is the 7 into 2k plus 3, like this. And then we're going to be able to simplify everything. Everything becomes beautiful. Everything becomes beautiful. Now, do you remember if you have ab to the power of n, which is the same as a n b n? Remember that? We're going to apply that here. It's going to be negative 2 squared, right? 3k plus 1 all squared. And we're going to get this. This is going to give us negative 4 into this is going to multiply this. We get 14k. This multiplying this, we get plus 21, like this. And then we end up getting, this is going to be 4. This is going to be 3k plus 1 all squared. And then this is going to give us minus, this is going to multiply this, we're going to get minus 56k, I believe, plus 84, and we can simplify this so that we're going to have, let me do it over here. I'm going to do it over here. So I'm going to get 4 into 9k squared plus 6k plus 1. All right. So when you simplify this squared, you're going to get this. All right, minus 56k plus 84, like that. So that we're going to get 36. Here's going to give us 36k squared plus 24k plus 1 minus 56k plus 84. All right, and this 36k squared will be there, but this 24 and a negative 56 is going to give us negative 32k. All right, and this plus 1 and this will give us plus 85, and it's going to give us 0. All right, it's going to give us 0, and now we can be able to use the quadratic formula to be able to solve things. Quadratic formula to be able to solve things from there, to be able to solve things right there. All right, right there, and then we're going to solve the quadratic, and then we're good. So you can use the quadratic formula to continue, and then we determine the values of k. We determine the values of k. We determine the values of k. All right, all right. Now we're going to look at a quadratic. How do we form a quadratic? How do you form a quadratic if the roots are given? Forming a quadratic when the roots are given. Forming a quadratic when the roots are given. So we know that x squared minus the sum of roots. Don't forget, we said when we add, we get it. When you add it, you get what is here, x. And then when we multiply, you get a product. Okay, product of roots. Go to 0. All right, and if you are given, that's the format. If they say that the roots of a quadratic equation are 3 and negative 4, 3 and negative 4. If they say that the roots are 3 and negative 4, 3 and negative 4. If you have 3 and negative 4 as the roots, it means that the sum of the roots is going to be 3. We're adding it, the roots. We're going to get negative 1. The product is going to be 3 times negative 4, and that's negative 12. Can you see that? So that we can be able to express, we got to be able to find the quadratic. It's going to be x squared minus the sum of the roots. The sum of the roots is negative. Can you see that? It's negative 1. We got negative 1 as the sum of roots, and then we put the x there. Plus the product of root. What's the product of 12? It's negative 12, like this, and it's going to 0. So we're going to get x plus 1x. So x squared plus 1x minus 12 is equal to 0. And we end up getting x squared plus x minus 12 is equal to 0. So you can be given the roots, and you can be told to look for the roots, to look for the quadratic equation. Now, also, I want to mention this quickly. Now, if you say sum of roots, all right, sum of roots, we can say that if the roots are alpha and beta, we don't know what the roots are. Let's go. Let's say that we are told that we have a quadratic equation, ax squared plus bx plus c is equal to 0. And we are saying that it could be ax squared plus the sum, right, of the roots with x plus the product of roots, which is the c part, is 0. If they say that the roots are, we don't know what the roots are. Let's say the roots are alpha and beta. We don't know what they are. It means that the sum, it means that the sum of roots is alpha plus beta. Is alpha plus beta. And what is that? It's alpha plus beta, right? Yeah, the sum of roots is alpha plus beta. When we solve it, we end up getting negative b over a. And then we say that the product of roots, the product of roots, the product of roots will give us, when we solve it, we also get c over a. There's a way to prove it. There's a way to prove it, but I don't want us to bother you with that. So product of roots, we have alpha and beta giving you that, and then product of root alpha beta giving you this. All right. We can be able to use this all the time. All right. So if we are given a quadratic, let's say 2x squared minus 3x plus 6, all right, and we are being told that it has roots alpha and beta. How do we find out? We know that the sum of roots is alpha plus beta, which is the same as what? Minus b over a. And that minus b, this is our minus b. So minus, and the b itself is negative 3. Minus and b is negative 3. Put it in there. Divide by a. This is our a, like that. And we get 3 over 2. Now our product of roots is alpha and beta. We're multiplying them. We said that when we do, we get c over a. What's our c? Our c is 6. Divided by our a, which is 2, and we get 3. All right? So the sum of roots is 3 over 2. And then the product of roots is 3. Can you be able to see that? Can you be able to see that? So basically, we're gonna be asked to manipulate. We're gonna be asked to do a lot of manipulation here. So let's look at some questions that can involve some manipulations. Let's say that say alpha and beta are roots of this, roots of what? Of this quadratic 3x squared plus 5x minus 1 is equal to 0. This is a root. This is a root. When I say that's a root, what does it mean? It means that you have when you solve it, you get maybe x is equal to 2, x is equal to 3. That's what they mean by the roots. When you solve this quadratic, those are the roots. But we don't know. That's why since we don't know, that's why they're using alpha and beta to represent them. Okay? That's why they're using alpha and beta to represent them. Now they're asking us to find the equation, find the equation, whose roots are 1 over alpha and 1 over beta. All right. But don't forget, the roots of this equation are alpha and beta. But now they want us to find an equation, an equation where the root is not alpha but it's 1 over alpha. It's not beta but it's 1 over beta. So what we do is that we add them. All right. The first thing is to do the sum of roots. What's the sum of root? The first root is 1 over alpha. We add it, summing. We are summing it to the second root, which is this. All right. And then this becomes a fraction. So we know that this will multiply that, we get beta. This will multiply that, we get alpha. This will multiply this, we get alpha beta. So we have alpha plus beta over alpha beta. And we know alpha plus beta is minus b over a. Don't forget, divided by alpha beta, which is c over a. All right. So we're going to plug it in there. The minus b, this is b. So minus 5 over a, which is 3. A is this a. And then we divide by c. C is negative 1 over a, which is 3. So we're going to have negative 5 over 3 divided by negative 1 over 3. Can you see that? Which is the same as negative 5 over 3. We change the sign to multiplication, and the 3 goes up and the negative 1 comes down. Now when we do that, we have negative 5 over 3 times 3 over negative 1. This cancels out. And we end up getting negative 5 on top and negative 1 on the bottom, and we get 5. That gives us 5. Right there. That gives us 5. Now we have to do the product of roots. The product of roots is going to be that 1 over alpha multiplied by 1 over beta, and we're going to get 1 over alpha beta. And that's going to be 1 over alpha beta is c over a, which is 1 divided by c over a, negative 1 over 3. And then that's going to give us 1 divided by negative 1 over 3, right? We're going to get 1 times, this one goes up 3, the negative 1 will come down, and we get negative 3. So this is the sum of roots. The roots alpha over beta, 1 over alpha, and then the 1 over beta. The sum of it is 5, and then the product of it is this negative 3. So we can be able to form the equation. So the new equation is going to be x squared minus, don't forget, sum of roots minus the sum of roots. The sum of root is 5, so 5x plus the product of root. The product of root is negative 3. And we're going to get 0. So we're going to get, we're going to get x squared minus 5x minus 3 is 0. And then we are good. And then we are good. And then we are good. So those are the things I was talking about manipulation. So we're going to end here. We're going to end here. But if you haven't yet subscribed, please subscribe to our channel so you can help us grow this channel together and make it as a family and help as many people around the world as possible. If you're already a subscriber, we thank you for supporting this channel and growing this channel together with us. I'll come to you another time with a very all comprehensive video. I'll come to you another time. Take care and bye.